Okay, so today we're going to talk about putting data into matrices. So a matrix is just a way of organizing data. If you look at this, these are the swimming, oh no, wait, I'm sorry. These are the medal counts for the United States and Germany and all these other countries in the Olympics in 2010. So you can see that the matrix is basically right here. As soon as I find a pen, all right, you could take this data and turn it into just that information, and then basically you'd make like a key to tell what some of it meant. So let's go back to this. So it basically says a matrix has m rows and n columns. So rows go this way, columns go up and down, okay? So we have 2 rows here and 3 columns. And this is not going to fit on your screen if I write that, but so this is a 2 by 3 matrix. So let's look at some other matrices and see how we can do that. So when you name a matrix, you usually name it with a capital letter, A, B, C, or D. And then all of the elements are like the little lowercase letters of the matrix, kind of like, you know, you're a smaller version of your parent. So this would be matrix A, and all of the little elements are lowercase a's. So when you look at this, A sub 1, 1, that basically means first row and first column. It tells where it is going to be. All right, A1, 2 would be the first row, right? We're in row 1, and then we're in the second column. All right, and it just keeps going like that. So let's look at, and now, you know, knowing how to name them is important, but adding and subtracting and doing all the operations with them is also very important. So let's look at adding and subtracting matrices. So let's say you're really just adding 4 different things at a time, okay? So you're going to go and add up the same elements. So this is the first row, first column here. 2 is in the first row, first column of this matrix, so we end up with 3. Then we have 2 is in the first row, second column. -3 is in the first row, second column of that one, so we've got -1. Then we've got 5 plus 1. All right, it's almost like combining like terms. You're just taking them from the same spot. And then the last one we have is -7 plus 0, and we get -7. So our new matrix, once we add them together, is 3, -1, 6, and -7. And that's all you do when you're adding and subtracting. There are some things to remember, though. Okay, they have to be exactly the same size, because if they weren't the same size, it wouldn't be possible. So let's say A is a 2 by 3 and B is a 2 by 3. Yep, you can do that one. But if C is a 3 by 2 and D is a 2 by 3, not going to happen. And I'm going to show you why. Let's do a 3 by 2. So you've got 3 rows. Okay, I'm just going to make up some numbers. 2, 5, 8, 1, 2, 3. Oh, and sorry, 2 columns. Let me go take off that last column there. All right, so this is a 3 by 2. Let's do 0, -5. All right, and then if you wanted to add, this is a 3 by 2, you want to add, this is a 3 by 2. You want to add a 2 by 3, okay? That's 2 rows and 3 columns, so 1, 2, 3, 7, 8, -9, just throw a -9 in there. All right, look, you don't have matching things. You have a first row, first column here. You have a first row, second column. What about this little guy? Can't do that, so you can't add those together. All right, we also have matrix equations. So go ahead and copy this one down, and I'll show you how we do this. All right, so basically all you're going to do is solve 4 different equations at one time. And you don't really do them all at one time. So you can basically, if you want, you can move this entire matrix over to the other side. Okay, but you're really just solving these like 4 different matrices. So you could either move the entire matrix over to the other side by adding the entire matrix to the other side. All right, I don't have a lot of room on this one, but I would add, you know, this matrix 1, 1, 3, 2, and you add all those same elements together. or you could just set it up as 4 different equations. It's up to you. So this is basically x minus 1 equals 0. That's your first element, what that's going to be. And then your next element would be x minus 3 equals 8. We're just taking this element and that element, putting them together in the same matrix. And then our next element is going to be what? X minus 1 is equal to 1. And then our very last one is going to be what? X minus 2 is equal to 9. All right, once you solve all of those, you're going to get another matrix. And I'm out of room on this little tiny screen that I've got, so I'm just going to write the answers in red. We know that this first one is going to be 1. The second one, first row, second column is going to be 2. And then the next one will be, what do? You add 3 to both sides, you get 11. And then you add another one over here where you add 2 to both sides and you get 11. So the new matrix is actually, let me just move this down. Oh, wow, I can do that. All right, is 1, 2, 11, and 11. And that's your new matrix right there. That's actually not your new matrix. That's what X is equal. That's what that X matrix is equal to. So if you went back and put this matrix in for X, you would get a true statement. And you would see what this is going to be. Let's go on and talk about solving some more complicated ones, okay? They do the same thing. You just set up 4 different matrices. Now this is a matrix equals another matrix. So now you're looking for missing elements inside of the matrix. So let's look to see what we got here. We got x squared is equal to 25. Okay, x squared is equal to 25. That's your first one. All right, now we're just going to go with the positive root on this. So I know we've been dealing with negative roots and things like that. So our very first element for x, we're not looking for a new matrix. We're actually looking for a value. X is going to be 5. Okay, so once you know that x is 5, you can maybe start making another matrix. Now we know 4 is 4. We don't have to do that. We know 3 is 3. We don't have to do that. The reflexive property. The only other one you need to do is 3y plus 12 equals y plus 18. 3y plus 12. Go ahead and solve this and then check it. All right, so I'm going to get 2y equals 6, so y is equal to 3. That's really all you're doing. You're finding what your missing elements are inside of each matrix. All right, try another one here. Now you've got a whole bunch of missing elements you got to find. I'll give you a minute to figure that one out. All right, now look, you can't do that one first. You got 2 variables. All right, that would be kind of challenging to do. All right, you'd be doing a guessing game. So let's go down here and figure out what y is first. All right, so it seems that y plus 4 is equal to 17, so y is going to be 13. Now you got that, and you know what to do. We've been doing this with our other things that we've been doing with our systems. So you've got 3x is equal to 13 plus 8. Now you got something going here. All right, so x is going to be, did I do that right? 7. Okay, I think that's right. Okay. All right, so now you can do the same thing when you multiply a matrix. All right, this is called scalar multiplication. If you ever want to know the name of it, it's called scalar multiplication. You're just multiplying a whole entire matrix by a number. So let's go ahead. I'll give you a minute to do that. All right, so once you have, let's do 5a. See, this is saying 5a minus 3b. So we're going to take and make 5a. Well, 5a is going to be, I don't know why this thing does this and then I can't get it to go away. All right, 5a is going to be 10, 15, negative 35, all right, 5, 20, and 25. That's your first one. And technically you're supposed to make a little square bracket. It takes me too long to make the square brackets when I type them, so these are technically a little bit wrong. You're supposed to have a little square bracket on this. All right, and then 3b, we want to do 3b. So let's get 3b going here and see what we got for that. So we've got 9, and 3 times 0 is 0. 6 times 3 is 18. And we got negative 3. We got 24, and then we've got 6. Okay, I'm going to scroll down. Oh, I'm so glad I can do that. All right, so now it's basically, what is the operation saying to do? 5a minus 3b. Okay, so 5a minus 3b. So I have to set them all up again. I know you probably don't, but I do. So I set them all up. Now first you ask, is this possible? Am I able to do these? Are they the same size exactly? Yep, they look like they are the same size. So let's go and add those up. 10 minus 9 is 1, 15 minus 0 is 15, and you get the idea. Negative 35 minus 18 is going to be like negative 53. Do you believe? Doing it in my head. 5 minus negative 3, be very careful. 5 minus a negative, it's a very tricky little operation. Some people forget. Even when you get up into higher level math, you forget to subtract a negative and actually make it a positive. 20 minus 24 should be negative 4. And then 25 minus 6 should be 19. And there you go. There's 5a minus 3b. Okay, so I am going to wait and do matrix multiplication tomorrow because it gets a little tricky. So we're going to do matrix multiplication on Thursday. If you want to read ahead, you can. If you want to look it up and see how to do it, it's actually very fun, and I want to spend a day doing that. So right now, your assignment is going to be on page 82 and 84, and I only need you only need to get started on these numbers right here. This can wait until tomorrow because that's multiplication. And it is not due Thursday. I got my days mixed up. It is actually due on Friday because I want you to go to college night tonight. Bring your parents, talk to the colleges, and have some fun. It'll be very fun. It's very fun to go to if you've never been. All right, have a great day.